Now we'll begin our next section of the class, and we are taking a little bit of a journey through the history of science up to Isaac Newton. And we've got to understand one important part of this history, which is that one of the most important driving factors in the history of science is the observation of the heavenly bodies. This can't be overestimated. In other words, the ability to see the night sky and to see the planets and the stars and their motions in the heavens has been a key factor in the development of physics and the development of science. And here we've got a diagram of the ancient Ptolemaic system. Now, Ptolemy was a Greek, an ancient Greek. He lived around 100 BC, and he recorded the movements of the planets, and the understanding at this time was a geocentric universe. And geo means earth, centric means center, so earth-centered. So you see here in this drawing, we've got the earth in the very center of this system. And if the earth is in the center, and you graph the movements of the planets in the sky over the course of a year, you get a very strange pattern, which is you get these epicycles. So the planet will appear one night to be in one position, and then it will kind of go backwards and make some kind of crazy orbit and do all these wild things. And what you're really seeing is the interference of the fact that the orbits take different times to go around the sun. But of course, they believed the Earth was in the center, so they had to draw the solar system and the movements of the planets as if the Earth was in the center, and you got these crazy, inexplicable epicycles. So, again, nothing really happened with this for about 1500 years, but then came along a fellow by the name of Nicholas Copernicus. Now we arrive at Galileo Galilei, and he is arguably the greatest figure in the history of science in many ways. But in my opinion, Newton takes the cake in that Newton is the one who really brings it all together. But what Galileo brings to the table is, first of all, he was a great inventor. He's one of the inventors of the telescope. He's usually credited solely as the inventor of the telescope, but actually there was somebody else who came up with a similar device around the same time. But Galileo was the first to begin using this device for astronomical observations, and the first one to really master its design. So he invents the telescope, and here's a picture of Galileo's actual first refracting telescope. And we know the telescope has been advanced tremendously since that time. So here's a modern telescope observatory on top of a mountain somewhere where there's not a lot of light pollution. And of course, here's the Hubble Space Telescope. So these telescopes have improved and been developed massively since that time. But the telescope allowed Galileo to further probe the solar system, especially, and he was an ardent and fierce defender of the Copernican system. And because of this, and he was very outspoken, he got in trouble with the Roman Catholic Church and with the Inquisition, but he defended his position till the end of his life. And he invented a lot of things, he published tons of papers, and really the main contribution here is that he is the one who begins using the scientific method in in the true modern sense of the word. Um, his theories have to be proven um, by observations. His theories have to they have to predict things, and you have to be able to show that those predictions are correct. So Galileo brings all of this together, um, and what we have at the end of Galileo's life is a very uh, well measured, well supported evidence for the Copernican system, that heliocentric or sun-centered solar system. Um, and he also worked on a lot of really important scientific problems of the day. For example, finding one's longitude at sea. In other words, uh, not latitude again is your distance above or below the equator. Longitude is where you are around the world from east to west. And um, this is a really difficult problem to solve when you're at sea and you have no landmarks. And the way he solved it was by inventing a very complex uh, device called an astrolabe, which basically was a telescope with some gauges and indicators on it that you aimed at Jupiter, and you could look at the moons of Jupiter and make observations and determine the absolute time based on the position of Jupiter's moons. And so if you knew the time and you knew how fast you were going, you could then calculate your longitude. So this was a major step in towards knowing one's longitude and towards better navigation. So that's just one example of one of the things that Galileo did. But really, the main thing is that he's bringing together the scientific method, but still the piece that's missing is the theoretical understanding of why heliocentrism works. And that's where Isaac Newton comes into play. And so now we move from Galileo to Isaac Newton.